today is going to be a little messed up, possibly because of picture day. But we're going to try to get through things as best we can. Well, for sports. You know, if you're in soccer, if you're in basketball. Exactly. Trina's going to disappear on us. But she still knows that she's got to get her homework done on this, and we're starting the next lesson today. Okay? Trying to finish things up. Yesterday, you know, although we learned something new, it wasn't terribly hard. We're going to be reviewing that right now. Okay? And I think that you're going to feel okay about it. So the first thing it asks for here, you know, and this was looking at those congruent triangles. What did we do yesterday? We basically looked at, hey, this part is matching this part in this location, and we named those parts. When we named parts that were, you know, basically in the same position on different polygons, what was that known as? It started with a C. It was not congruent.
Oh, the C.
It was a long word. Corresponding. So we learned, all of us learned, about this thing called CPCTC. Corresponding parts of congruent triangles were congruent. Okay? That if we were told that we had congruent triangles, then the corresponding parts obviously had to be congruent. And so here they show us two different triangles, and we have indicated on here which parts are congruent by the equal number of slashes or the equal number of those arcs, those curves. And we have to say which are congruent. Now, order matters, okay, because we want to make sure that they're matching up. So LMN, is that congruent to RTS? That's going this 1, then the 3. RTS,
Well, yeah, that's congruent.
RTS, it goes 1, and then the 3. Well, that seems like a possibility. LMN, that's the same as before. STR, so instead of going 1 to 3, it's going from the 3 side to the 1 side. That doesn't seem right to me. LMN, same as ever. RST, well, again, it's going to match up differently. LMN was 1 to 3. RST, 2 to 3. Nope. And then TRS. TRS goes 1 to 2. So the one where we have the corresponding parts named in the same order is this A, LMN is congruent to RTS. Does that make sense to you guys? Hopefully. We're trying to make sure we have things in the same order so that they are corresponding. Okay. Here it says name all the corresponding congruent angles for the congruent triangles. So here we have to work out which is matching with which. And you notice that here they're only naming the angles with the vertex. Okay? So what's matching? L matches to R. That's good, that's good. No. That's good. Okay, as far as that. Let's look at what's 2. RS and LN. Oh, sorry, I'm looking at sides and I should be looking at angles. We looked at R's and L's. Now we can see the M and T, which are angles, are congruent. So, which has M and T together?
D.
Not this, not this. We do have it here. So we should have N and S matching. Of course we do. And so you have your answer. Any questions on that? You start to see, like, your homework doesn't look that bad for that part. other than it can be tedious, because you're gonna have to write stuff like this out. You know, explain, show all the congruent sides, all the corresponding sides, all the corresponding angles. It's tedious, but it's doable. Okay? Name the corresponding congruent sides for the congruent triangles. So previously we had to look at angles, now you're looking at sides. All you have to do is pick the one that matches up. So instead of the angles, now we're looking at LM and TR or RT. Good, good. No. No. We're already down to these two because those work for us. Okay. Switch over to the 2/ side, LN and RS. LN, RS. No. And so we already know that we're here. You know, it's kind of like, you feel like you're sorting things back in kindergarten, except for the fact that it takes a little bit of thinking. You're not just matching red to red or square to square.
High school girls basketball and high school girls soccer to the cafeteria for pictures. High school girls basketball and high school girls soccer.
I'm like, I know your hair's longer, but that's about it. Okay. So here's where it actually gets a little trickier. And it's not that much trickier other than the fact that, oh no, now I have to do algebra. Right? And none of us are happy doing algebra. They tell us that ABC is congruent to DEF. Okay? They show us which sides are congruent. And from that we can see which angles are congruent. It tells us to find X. So all I have to be concerned with is where I have something involving X. Should I be concerned about the stuff that shows me Y? No, it's not even necessary. Now how can I solve that, given that information that I have?
6x plus 5 equals 9x minus 4.
Exactly. They're congruent because they're corresponding parts. They have the same measure. They're equal to each other. I solve for this. Okay? I can subtract 6x, subtract 6x. I'm left with 5 is equal to 3x minus 4. Add 40 here, add 40 here. 9 is equal to 3x. And then I divide by 3. 3 is equal to x. Not too bad. Not too bad at all. And now they want us to find the measure of angle A. Angle A is where we have this vertex. We know this. What other piece of information is going to help us determine what y is? Well, we have to figure out y in order to figure out the measure of angle
What
A.
did he versus D?
Vertex D, yes, this angle D, we know is congruent to angle A. Okay? D is congruent to angle A. Do you have to write all this out in your work? No, I'm just trying to make sure that you follow my thinking. Okay? Angle D is congruent to angle A. So the measure of D is equal to the measure of A. So I could say 12y plus 3 is equal to 9y plus 18. Still do the algebra. Subtract 9y, subtract 9y. Subtract 3, subtract 3. Divide both sides by 3, I have y equals 5. Am I done? It's not an answer choice. I'm not done. We weren't asked to find y, we were asked to find 12y plus 3. And equals the measure of angle A. And that's 12 times 5 plus 3 equals the measure of angle A. 12 times 5 is 60. Add 3, and you should get 63. It's magic. That's as difficult as the homework's going to be. Okay? Given that ABC, triangle ABC is congruent to DEF, which of these is true? So we have to make sure we understand what are the corresponding angles. They're the ones that are in the same position, even when we name them. So is A corresponding to E? A and E? No. Okay. How about C and D? No. A, B, congruent to DE. A, B, D, E. That's looking pretty good. It's the same positions. D, C, F, D. No. Those don't match. We're looking for the corresponding locations, even in the naming. Okay. So just a quick note that you have homework on this tonight. And I didn't mention this to you guys yesterday. I don't think, I know I did for fourth period. I've taken away your odd numbers.
No.
And I know, for some people it's really going to hurt because, you know, they like that to be able to check their work. And that was what it was intended. Okay, it was for you to check your work. What?
How? What is the problem?
How do you check your work with the odd numbers?
Yeah.
There's answers in the book?
Yeah, the answers in the book have like numbers in it.
The whole time, yes. Okay, I know which of, trust me, I know which of you never looked at it. Okay, but there,
more.
what?
Can you explain more? I'm not getting it.
Okay, so
It doesn't really make a difference. There was answers at the back of the book
for the
for
odd
all
numbers.
the odd numbers.
So it was only the odd numbers?
So,
Only the odd.
yeah.
I knew there were answers at the back of the book, but I haven't
Yeah.
online textbook. And I didn't know
I
how to
thought it
find
was circling green.
No. It's just odd.
Okay, in your physical textbook, there was answers at the back of the book.
Yeah, I never had them.
Okay. You did not pick one up or what?
No, I never used it.
Ah, well, there were people that did. And I had no problem with you checking the answers. Okay, I had no problem on occasion. I forgot to. Let me hurry and give me what you can, right? That happens. But there are a number of students that are not using that in a good way, that I feel that I have to take that away. So now you don't have that advantage. Your only advantage is talk to Miss Lisa. Okay? I'm going to try to make sure that I have less questions. Okay? But there are going to be even numbers so that you do not have anything to look on other than your notes, other than the tutorials. What page is this? I do not know.
It's
Two.
40 something.
Yeah, I have it in red lead, but I don't know off the top of my head. Okay? I will say, let's look at a couple right now though.
It's 250.
Okay? We're gonna look at a couple right now.
It's
You're already done?
256.
That's fine.
You finished it?
I know Luke had started because he had a question and then he didn't have a question. Okay? This ends up being a little bit fuzzy, but hopefully we can make sense of this. So, as I said, we're doing even numbers. Okay? I'm not gonna do the whole homework for you. but I wanna give us a start.
He said, oh, yeah, I see.
So you have an opportunity for questions.
I was gonna ask you for those.
Yes,
Are we still submitting like,
Yes.
online?
yes. Okay. To be fair for everyone, that's what we're gonna do. Okay. So here, like I said, we're doing questions 10 through 20 even. So here are your first 4. Okay, we're not gonna do each and every one. But I wanna do some examples. So that hopefully it will take care of those questions. Okay? So show that polygons are congruent by identifying all the congruent corresponding parts and then write the congruent statement. Okay, this is just like an example that we had in class yesterday where we have to name these things. We have to name the sides that are congruent. So in this case, we have GH is congruent to JK. Actually, sorry, the naming is important. GH to KJ. Just to make sure that I am putting things as much in the right order as I can. Okay? With 2 slashes, I have HK congruent to JG. And then also congruent is this third side to itself, technically. Now in this case, they didn't include it because it's the same line. I'd be okay if you didn't include it. I'd be okay if you did say that, you know, GK is congruent to KG. Either which way would work. It's whatever's going to be more helpful in your brain to keep things straight. Okay? So I've named my congruent sides. I need to name congruent angles. Okay? So I have angle, and they didn't name these separately. So I know I have angle J congruent to angle H, but they didn't separate out JKG and HGK. And then on the opposite side of things, we would have JGK congruent to HKG. So now I've taken care of all angles, all sides. I could include the middle one or not because they have them touching. It is the same line. That's the congruent corresponding parts. Okay? Now I need to write the congruent statement. The congruent statement is this triangle is congruent to that triangle. But just like you saw in the previous example, we have to make sure that we have the corresponding parts in the same order. So I could say triangle JGK is congruent to HKG. So this here is my congruence statement. These are my corresponding angles and sides. The second thing is my congruent statement. Okay, and then you're going to do the same thing for 12. Okay, unfortunately, you don't get to just do the slashes or the arcs. They want you to write it out. This is that tediousness that we talked about. Let's look at example 14. It tells us with these 2 polygons congruent to one another, we need to solve for y. Okay? So where do I have y? Okay, this angle here includes the
And
Y.
then T.
And then this angle here includes the Y. Now, we gotta hope that they're congruent to one another. We gotta hope that they are actually the same corresponding angle, right? So let's make sure that they are. Okay? I'm looking at angle D and angle T. D and T, here's a short way to figure out, oh, they are corresponding. They're in the same location as we're naming it. Yes. Because if they weren't, we wouldn't be able to know that they were equal to one another.
Well, it's not
Now
the
we know
exact
that.
same, but like they are pretty much the same. Like they're just like on the same line with the same angle. So
I'm not sure. So in this case, because they're listed as the third vertex, the third point, they're at the same location. I could also see that here. If I took this
And flip it.
and I flipped it,
D would
actually,
be-
I would have to flip it this way.
Yeah.
I couldn't rotate it. I'd have to flip it this way. But I can see that these are congruent. So that means I set 2y minus 31 equal to y plus 11. And then I solve. Subtract y, add 31, add 31. That wasn't too bad, right? We don't have to solve for anything else other than solve for y. And then in 16, you'll use that same procedure, solve for w. Is your homework looking not bad? Not bad. Not great? Not bad. This is gonna be like the bane of your existence. I wouldn't like doing it either, but it needs to get done.
Wait, so that's it?
Yeah, that's what I need to fix on my home.
We haven't done everything. I just showed an example, you do the next one. I showed you this one, you do the next one.
No, I'm just saying, like, for 14, that would that's it.
Yeah, that was it. That's all you needed to do for 14. You found y. So, let's look at the next ones. 18. Okay, you're going to be doing 18 and 20. It says find x and y. Well, it tells us what this is. By the arcs, it tells us what this is. We already know this. Find y.
Oh,
There's an easy way to do this one.
so 2x.
40, or whatever that number is.
It's even easier than you think.
Yeah.
Soup,
So you replace the y
Okay.
with 40? And
replace the y with 40.
And
Yeah,
then,
okay, I was thinking it was that.
Replace the y with 40. First off, y,
because they're congruent.
y equals 40 degrees because of vertical angles,
Oh,
And then
right?
The
And
two
if we know that this is 40,
the two other angles in the triangle.
40 plus 2x plus 2x equals what?
180.
180.
Or just 4x.
Yeah, I could do it that way too. 40 plus 4x is equal to 180. 40 plus 4x equals 180. 4x is equal to 140. X is equal to
35.
You're right. So I have y, I have x. Have I done that? Yes. And you're going to do the same sort of thing on 20. And then here seems like it's the hardest just because it didn't give you a picture. You have to make your own picture. It says draw and label a picture. Draw and label a figure. Represent. So we have a triangle ABC that's congruent to DEF. So we're going to make an ABC, and it may not match. We can always add if we need to. A, B, C, D, E, F. They tell us AB is 7, BC is 9, AC is 11 plus X. DF is 3X minus 13. DE 2Y minus 5. And we have to figure out what's X and Y. Can we do that? Definitely. We already know that these two triangles are congruent. We can look at their corresponding parts and solve. Okay? In order to solve for X, I know that DF is corresponding and congruent to AC. Okay? DF is congruent to AC because they are corresponding parts. Their measures are equal to one another. So I can say 11 plus X is equal to 3X minus 13. I can subtract X from the left, bring it to the right. I can add 13 to the right, add 13 to the left. And I have 2 equal to X. 12 equal to X. So I've solved for X. Now solving for Y is even simpler.
At this time, please release all
I know that
cheerleaders.
AB,
All varsity
side AB is congruent and corresponding to DE. So 7 is equal to 2Y minus 5. Add 5 to both sides, 12 is equal to 2Y. That means that 6 is equal to Y. And I've solved for Y. And then you do the same procedure for 30. And then your homework's done.
Solve number 20.
What was that?
Number 20.
I would prefer if you do it on your own, considering I need you to have a little bit of practice. What are you stuck on?
It's just it has 2 variables in it, and I was having trouble
Okay.
when I stacked them on top of each other.
Well, we have to work out where we have congruent sides, okay? So this here is congruent to this, right?
I can show you my work.
Yeah, I can understand. Let me take a look at it for a second. So they've given you enough information between this and this
Mhm.
to work out what this is equal to,
I got the
first off.
It's equal to 142.
142?
That's what I got.
No.
Or
This
that's
one is gonna be 180,
140.
subtract 90, subtract 52. This is an acute
Oh,
angle, it's
so
gonna be a
it'd be
much smaller
180
number.
minus 142. Alright.
Okay.
That's what I got wrong, I think.
Yes. 180 subtract 142.
That probably messed up my whole equation.
Okay. That might have. So knowing what this is equal to is definitely going to help you.
Yes.
Okay, let's move on because we need to get in starting on the next lesson. So now what we're gonna do is prove that triangles are congruent to one another by looking at their sides. That if all 3 sides are congruent, the triangles are congruent. We don't need to have everything congruent necessarily. We don't have to know that everything's congruent. All we need to know is that there's 3 sides that are congruent, or that we have side angle side. So we have these 2 new postulates, side, 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 and side angle side. Make sure that you have this. Make sure you have it readily available for you. Okay? And then they talk about this new vocabulary, they included angle, the angle between two different sides. Okay, that is the included angle. Okay, so side, side, side congruence. If AB is congruent to ED, and BC is congruent to EF, and CA congruent to DF, then these triangles are congruent. It makes sense. If they have the exact same lengths, obviously they're gonna have the exact same angles. It's the only way that this could work. So we're gonna make use of this. They ask us to write a flow proof, not one of our favorites. We are given that QU, I went with the wrong way. QU is congruent to AD. So this side is congruent to this side. And that QD is congruent to AU. They gave that to us in our picture. So given that we have those sides congruent, they want us to prove that QUD is congruent to ADU. Now we're supposed to use side, side, side. Did they give us any information about the third side of the triangle? They didn't. But the two triangles are touching one another, so that third side is shared between both triangles, so it is congruent to itself. Because it's a shared side. Okay? If you need to for yourself, just go, hey, I know that's congruent to itself. Okay? And this seems awkward for the type of proof that they're using. Okay? But here they use both givens. You know, remember, a flow proof is something where we say, well, we have this information, and we have, which leads to this information, and we also have this information that leads to there too, and so we get to, you know, our answer. It ends up being like a flow chart. And this one, I admit, looks like an awkward one to me. So they have this given and this given that we had from the previous slide. Okay, and they also say, hey, that third side, DU, if I go back, DU is this third side. I say, hey, it is already congruent to itself because of the reflexive property. You know, the reflexive property, the symmetric property, the transitive property that we learned earlier, those still apply as we talk about these sides. Okay? We talked about them earlier when we were looking at points, when we were looking at different measures, when we were looking at sides. It doesn't disappear now that we're looking at triangles and polygons. So we have side. These two sides that are corresponding are congruent. These two sides that are corresponding are congruent. This, which is itself, is congruent because of the reflexive property. And as a result, these three sides show through side, 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 that postulate for the side, 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 that those two triangles are congruent. I admit, it wouldn't be the way that I show it, but this is how they chose to show it. Is it okay if I move forward? Mostly? Okay, so what information is missing from this flow proof? We're given that AC is congruent to AB. So So that's this side is congruent to this side. We know that D, that's a midpoint. We need to prove that ADC and ADB are congruent. What did you say, Gabby?
Do you think AB equals congruent to AB since it's cluster?
So AD congruent to AD. I would agree. And they already gave us that reason right there, that it's reflexive. Not too bad so far, right? Given, reflexive. Hey, I have side, side, side. So these two triangles are congruent. And we knew that these two were congruent because B was the midpoint. Everything builds. Whew. Okay, this doesn't look quite so friendly. Which is exactly why I wanted to get to this as soon as we could. We have a triangle. And they give us the 3 vertices of the triangle. And then they give us the name of another triangle and its 3 vertices. First off, they want us to graph the triangles. So we need to create, that X, Y, and put both triangles on the same graph. Then we need to use the graph to make a conjecture as to whether they're congruent or not and explain. So this is where we're going to have to match those corresponding parts, right? And then it says, write a logical argument that uses the coordinate geometry to support the conjecture you made. Whew. Okay. So we already kind of read through that. Here's where they graph things. Okay, let's check things out to make sure that they actually put these in the right order, right? So we need to make sure we have vertices. D at -5, -1. V, -1, -2. W, -7, -4. And then we're going to have L at 1, -5. Now, we don't know exactly which way these are corresponding as of yet, or if they're corresponding. And M at 4, -7. Okay, so let's look. D, -5, -1. Looks good. V, -1, -2. W, -7, -4. Looks good so far. Okay. L, +1, -5. P, +2, -1. And then M, +4, -7. Okay. Those look good. Now we gotta see which parts are corresponding, right? In order to work out, any sort of conjecture. Okay, so I can see that this VW looks to be the longest side. It goes over, let's see, 1, 2, 3, 4, 5, 6 in the X direction and changes by 2 in the Y direction. With a change in 6 and a change by 2. I would say that because of those changes, these two are congruent. Would we agree? And then we're going to check for the next side. Change of 4 and 1. Okay, where do I see a change of 4 and 1? So those two sides are congruent. Let's look for the last side. Change by 2, change by 3. Okay? Change by 2, change by 3. That means the third side is congruent. Okay? So I'm looking at this and I'm thinking, well, hey, what do we need to do next? It says, from the graph, it appears that they have the same shape. We conjecture that they're congruent. They kind of look alike. They suggest that we could use the distance formula to show that all the corresponding sides have the same measure. We look for the corresponding by checking their x and y changes. I think that either are okay to do so. They measured the length of each of these by using this distance formula. We did a shorthand version of that. Okay, rather than using the distance formula, like I said, we looked for the change in x and the change in y and made sure that we had the same between each. And in this case, they're going to have to go through this distance formula each and every time to show which are corresponding in length. So because they could prove using the distance formula, or we tried to using checking our rises and runs, we know that all of these are equal, so they're congruent. And because all three sides have these corresponding and congruent sides, the triangles themselves are congruent by this side, side, side. Okay? Can we determine whether or not these two triangles are congruent? Could you determine if they're congruent or not? I think we can, but are they congruent or not? Okay, again, I can use the distance formula, or I can start checking for rises and runs. Okay, whichever one you're more comfortable with. Okay, so I have over 4 up 2. Is there one that's over 4 up 2? Over 4 up 2. I would say that those two are congruent. Okay. Over 5. 1, 2, 3, 4, 5 up 2. 1, 2, 3, 4, 5 down 2. Same length. I kind of like my way better than the distance formula. It's just easier to count rather than to plug it in and do square roots. Okay. Over 1, down 4, over 1, change of 4. So, is A, B, C, so that's going the 2, the 1, then the 3, D, E, F, the 2, the 1, the 3. Are they congruent? Yes. Questions on that? Is it okay that we do it this way where we count the rises and runs rather than the distance formula? I kind of like it. That's immediately where my brain goes rather than trying to, like, I looked at it and went, I wonder if we're going to have to use that distance formula. Yeah, we can. It's always going to work, but it's going to be a lot more work on the page. Okay? And I do like you to explain your thinking. Where are we at for right now? I can never remember the times of when we're done for this year. We got 5 more minutes. Okay. That means we might get more homework done tomorrow, which that sounds good to me too. So rather than side, side, side all the time, we could also use side, angle, side. So as you can see here, if two sides have corresponding congruent parts in the other triangle, if the angle between those two sides is corresponding and congruent on the other, then we have congruent triangles. And if we have the same angle here and here, obviously the side that's opposite them are going to be of the same length. Okay, that's the only way that those triangles can work. So here we're going to use side angle side to prove that these wings are congruent. It says the wings of one type of moth form two triangles. Write a two-column proof to prove that FEG, okay, so they're saying triangle FEG is congruent to HIG. Okay, that's the ones that they say are corresponding. So what that means is this is corresponding to this, and then EG is corresponding to IG, right? It says if we know that EI, that kind of got moved a little bit. These should be over here. I don't know how they kind of slid over. We know that EI, this whole thing, and FH, this whole thing. So from here to here, we know that this is congruent to, well, that makes it difficult between everything, huh? That the whole one is congruent to itself. Okay, and G is the midpoint. This is the midpoint of both of these larger ones. So do you remember what a two-column proof looks like? That's where we're going to be starting for tomorrow. Okay, we have our statements, and we have our reasons. This is quite often your theorems, your postulates, your definitions. Okay, and we always start with our given and what we're trying to prove. And so we will finish up with that tomorrow and start on our homework before. So that by the time we reach Friday, we're reviewing for the test.